So here we are. We've just finished up our chapter 2, and then we're looking forward to a test. I mean, it's open right now, and it'll stay open through the 4th, because next Tuesday, the 5th, we will be going on to chapter 3. So, any questions about anything related to that? I was going to go through a review like that practice, and we'll just look at the problems and see what's going on with them, and I'll try to enlighten you. Let's see. Get the right class here. Hold on, I'll be right back. All right, so it's a little practice test we can go through, and I'll just kind of see what questions y'all have as we go through. All right, anybody want to take a stab at that? Kind of help matters along. What can we do to find these? They want both the domain and the range. How would we find the domain? It's a set of ordered pairs. All right. Well, I'm going to assume that y'all are alive and just maybe need to get woken up. All right. The domain is just all the set of the x values. So the first term in every one of those ordered pairs. And you know what? There's only one domain value because this repeats the value, the x value. But the range is the set of y values. Now, here's the big question, and it's sometimes kind of hard to get straight in your head. What happens when we repeat x values in regards to a function? Well, if every x value can only go to one y value, that's kind of by definition. In other words, if you take x squared, for example, and you put in, let me just show you visually. And this is probably the best example. Is just using a parabola. All right, so on a parabola, if we go along each one of these x's along here is only going to go, so 1 just goes to one value, 2 only goes to one value, -1 only goes to one value. So this is an idea, this is a visual of a function. But like, let's see if I can get this to do this. All right, but here is a situation sort of like what we've got. We've got multiple x values. In other words, here, 1 goes to -1, 1 goes to 1. 2 goes to this value here. It's a rational, irrational number. Same thing here. 4 goes to 2 and -2. So there's a problem with this one because this one clearly breaks the vertical line test. So in that case, this is not a function. So anytime x repeats, you got a problem. Anytime x goes to more than one y value, there's a problem with the function. It's not a function. It's a relation. Okay. This one is just basically you want to grab stuff off of here, and it's just go to f of 4. And remember, 4 is the x. It's what's going inside. It's the input. So if we go to x is equal to 4, which is right here, we clearly have to go up, and it appears to be 8. Do y'all agree with that? Am I seeing that right?
Yes.
All right, here's another one to evaluate. The best way to handle this is just do it like on that board, and I'm going to take a little picture of it and tote it over there. And then we'll come back and put them in here. All right, so here we go. All right, so there's just three different things they want us to evaluate. They want to evaluate A, which is f of -5. So we just drop -5 inside of that function. All right, so inside the R is now a -5. There's already a +5 in there. So that ends up being 0 plus 2, which is just 2. Make sense? This one, we're going to put a 44 in there. be a plus. So 44 and 5 is 49, which ends up being a perfect square. So 2, 9, and what about C? C's got a variable in it, but we're still going to replace the R with that x minus 5. So there's going to be another variable in there, and likely we probably won't be able to simplify it down to a number. Ah, and the plus 2 is not on the inside, is it? It's plus 5. And then plus 2 is on the outside. So the 5 and the negative 5 take each other out, so it's just the square root of x plus 2. All right, any questions about that? Did I do anything funny that you can see, or questions at all?
No.
All right, so I don't really need to put them in here, but let's just go ahead and do it. So 2 was 9, and then this was all right. So they want us to graph this thing and then transform it. So there's 3 transformations here. First of all, let's just kind of go backwards. Let's go from right to left. The negative 3 is a vertical shift that moves it down. So we can rule out A and B. All right. We can rule out A and B because this has got to means the point there, that vertex has got to be down 3, not above 3. Now the negative 2 is the opposite of what we might think it. That's the left to right movement. That's the XY movement. So the negative 3, it's not negative 2, it's positive 2 because we're not looking at the negative sign. The negative sign is built in there. So that doesn't do us any good because both of these have that same shift. But the negative sign here, that's what turns the V upside down. So what's the difference between these two? I don't see any difference. So 1, 2, 3. Oh, this one's only going down 2, so it's this one. So this one has got a shift of, they got them mixed up. So this one is 2 down and 3 over, and then this one is the right one. All right. Any questions about that? So you kind of got to pay attention to some detail on this one. Oops, what did I leave undone? Oh, okay. What transformations are needed in order to obtain the graph? So all apply. So it's a reflection about the x-axis. That's the turning upside down. Uh, and then there's a vertical and then the horizontal shift, I call them, but they say translation. There's no stretching or shrinking. Stretching or shrinking has to do with whether there's a number here or not in front of that um, absolute value sign. And then y-axis, that is when we throw a negative x inside, and that would uh, flip-flop it like that. All right, is this a function? Remember, if we got a function, we got to be able to solve it for y. All right. So let's ah, so I'm just trying to make a line there. So all right, so they gave us that thing. That's x squared plus y is equal to 36. So we got to be able to solve this thing for y. So that's not too hard because we just got to subtract x squared from each side. And so then we've got y is equal to 36 all right. So it can be solved for y. So that's definitely a function. Okay, so write the point slope form of the Lyon's equation satisfying the given condition. So this is where we just got to basically make an equation. And they wanted to put it on slope intercept form. In other words, it's got to be solved for y. All right, so I must have closed the little thing. Okay, so we had slope in 4, and then we had 7, 3. So remember, m is 4. And then and we want to build an equation. All right, so what we need to do the equation is we need this little guy, our this is what they call the point slope form. You can anytime you want to build an equation, this is what you use. All right. So this is x1, y1, and then this is m. So and then we're going to simplify it. We got to distribute there before we can complete the solving for y. So there we go. That's what they want. Oops. All right. I'm thinking y'all are dead out there. So what's going on? I'm not hearing anything. What's going on? I could easily go back to sleep here, so I'm not surprised y'all aren't talking, but
You see the chat?
just wondering what y'all are doing. Wondering if I'm getting through to you.
Can you hear us?
All right, so they want two things. First of all, they want it set up in the point slope form, and then they want it simplified to the y is equal to mx plus b. All right, there's a piecewise function, meaning that at this value of x is equal to 2, it's going to transform to another function on the other side. So, all right, so x plus 4. All right, let's just look at each one of these. I guess we're going to have to assume 2, 4, 6, 8, 10. Yeah. So the first one is 2. All right. Now, let me just kind of let you in on a couple of little secrets to help eliminate this. X plus 4 and x minus 4, both of those are what we would call a positive slope. In other words, the line has to be laying like this. In other words, as we go across on the x-axis, the slope is it's getting higher. The y values are getting higher. So we can eliminate C and D from this. All right. So what can we do to now figure out the right one from B and C? It looks like it's just a matter of picking the dot. Now, for less than 2, and remember this line right here is 2 because each one of these is 2, or for 2, for the first one, x plus 4, it's less than 2. So that means then on that left side, there has to be a circle. So it's got to be this one. Because immediately then upon getting to the 2, that 2 goes to the new line. So that's why we use this one. So this means it does not include 2, hence the circle. And this one does include 2 when it starts off again. Let's see, the range on this, it's basically everything. Okay. Yeah, it's in negative infinity to infinity. Because we're looking at the y. So eventually all of the y-axis would be covered up. They even overlap at this point, so there's no problem with that 2 there, even if there was a hole in both of them. So it's just going to go on out into infinity on both sides for the y. All right, what about odd and even? Y'all remember that? That one takes a little bit of work. Make us some room here. So what was the name of that? It said h of x is equal to 4x squared minus 6. All right, so now That's I'm going to go through the procedure to work it out, but I think I can prognosticate enough to tell you that this is even. It's not going to be odd, and it's not going to be neither. And how would I make that guess? Just based upon the powers. They're both even powers. Now remember, what did we do to? Let's see. I want to get that definition for you. Let's uh, let's look at the section with that in it. I want to just make sure you get the formal definition so you see what I'm talking about. Let's see, was it 2.2 or 2.3? We'll see. Funny thing is, I go over this in my math 130. Yeah, there we go. All right. So a function is even if f of negative x is the same as the original function. That's what that means. So if we substitute negative x in for x in that function, if it looks just like it did before we did the substitution, then we're all right. All right, and thanks for that chiming in on things, Nicholas. I didn't see you until just now. I don't know why. Sometimes I see the little yellow thing saying somebody's texting. But because I need to have, I need to also have the participants list open because in case somebody talks, I can see who it is. All right, so let's just go ahead and all right. So what we're gonna do? Put a negative x in there. All right. Now, whenever you got an even number of negative signs and you're multiplying, it's going to end up being positive. So negative x times negative x is just plain old x squared. So 4x squared minus sign. And then the same thing here, because we got x, um, x, you got 6 negative signs. So multiply negative x times 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 negative x, you end up with, all right. So all right. Uh, this one didn't ask about odd, but I'll just throw in it. If it had been odd, then the function that comes out about when you do this is it would be equal to throwing a negative sign in front of the whole thing and evaluate and simplifying it, distributing negative to both terms. So it's not odd, it's even. And like I said, it's the easiest way to tell is just to look at the powers. If the powers are both even powers, then it's an even function. And if the powers are both odd, then it's odd. Now, neither could fall into some other categories, but if it was mixed, in other words, if there was a four and a three power. All right. Any questions? All right, let's go back. So it's going to be symmetric with regard to the y-axis. In other words, it's a mirror image. All right, because that's the definition of an even function. So see that? So an even function is going to be symmetric in regard to the y-axis. It's a big mirror image. All right, so find the average rate of change. All right, so that's just a matter of the slope. Let me grab that one. All right, so find the average rate of change. So that's just the slope. So what we're going to do is just stick it in. I'll just even write this up here. It's just that since we're not dealing with y, you got f of x up there. All right, so we need to find down here, we can usually just put in 49 minus 4. Okay, and up here is going to be f of 49 minus f of 4. And then we got to substitute in. So that's square root of 49 minus square root of 4 over 49. And then that comes out to, let's say 5 goes, that's 1/9, isn't it? So 5 goes into 45 9 times and into itself once. All right, any questions? Same thing. I'm going to set it up. I'm going to see if y'all can work it, all right? Because they're just giving you 2 of them. All right, give that one a try. See if you can do it. Like I said, it's a repeater. Just wanted to look at a few things just to see what we're dealing with. So, anybody figuring that one out? So we're just doing the same thing. So it's just going to be kind of crowded up there because this is a longer function. Well, I'll just go ahead and put this in first. And you got to put in parentheses. I mean, you got to put up something there, a big parentheses or a bracket, because you're going to subtract whatever comes. So that's 2 squared plus 3 times 2. And that's eventually going to be 3, but I wanted to get the tough parts out. So this is 25 plus 15. I'll tell you what, just save a little bit of room. So 5 squared is 25. 3 times 5 is 15. So that's 40. 2 squared is 4. And 3 times 2 is 6. So that's 10, right? So 2 squared is 4. 3 times 2 is 6. 6 plus 4 is 10. Just to make it a little bit shorter. So this one comes out to be a whole number, even though it looked messy at the beginning. All right, so here's an application. A company that manufactures bicycles has a fixed cost of $80,000. It costs $150 to produce each bicycle. The cost of the company is the sum of its fixed cost and variable costs. So what we got is it's going to be 80 no matter what. Plus, so the total cost of the company is its fixed cost plus what it says sum, which means add, and variable cost. All right. So there's the function. You could swap it around 150x plus 80, and it'd be in the y is equal to mx plus b format. As a matter of fact, let's go ahead and do that just to be consistent. All right, determine the $90. So what we got to do is, I'm just going to do it on this calculator because it's 150 times 90. Hold on a second. So that's going to be $13,000 to produce the bicycles plus the 80,000. So it's going to get end up costing 93,500. Now this one would be wrong because it doesn't cost $90 to produce bicycles. It costs the 13 the other number, 13,500. Oh, I'm sorry. They just put 93,500 in there. There we go. So this is just putting it in words what that means. I mean, this would not be right, the A, because the least it's going to cost to produce one bicycle, you got to have $80,000 plus $150. So 80,150. So that one's not right. All right, here's another one to write an equation. Now, this one, let's go ahead and just type it in. Let's see, y minus 6. So, um, so they're giving us two things. So tell us it's a y-intercept. So that's 0, 6, and then the slope is negative 4/5. All right, so y minus 6 is equal to negative 4/5 x minus 0, which is just going to be so that's what the slope intercept form. All right, because there's a 0 there for x. Now, to get it in the final form, we're just going to plus 6 both sides. So then this is going to be y is equal to negative plus 6. And essentially what it amounts to is, since they're giving you the slope and they're giving you the y-intercept, you could just jump straight to this one if needed to. But this one's asking for both. All right. So there's two things happening here. I'll just let you see the graph of all right. That's the basic square root function. So what we were given there is we're given a shift of 3 on the x-axis, and we don't look at the sign. Now, if it was positive, we'd have to think that it's a negative of a negative. So what that essentially means is when we have x minus 3, we have to take the opposite sign there. So it's a 3 shift to the plus side. So this is a shift to the right. All right, because it's inside the function. And inside the function, the shifts go the opposite of what the sign is there. All right, now the other thing is a stretching by a factor of 2 vertically. So just to kind of show it to you, see that? It stretches it up vertically, it pulls it up, and it also pushes it over 3, as I said. That's the only two things there. Oh, what was the other thing? Oh, okay. Well, it's this one. I didn't know they were asking that, wouldn't it? Okay, determine whether the following statement makes sense or does not make sense and explain your reasoning. The slope of one line was computed to be negative 3/5, and the slope of the second line is computed to be negative 5/3. So the lines are perpendicular. That's a false statement because it would be perpendicular if you have reciprocal and the sign change. Here the sign stays negative, so this is not perpendicular. Matter of fact, it's not, we can say it's not perpendicular. So this right here is the answer. Oops, I'm sorry. Did I press B by accident? But that's definitely it, because the only other one that does not make sense is also a false statement. It says the statement does not make sense because perpendicular lines have the same slope, and that's false. Parallel lines have the same slope. All right, open intervals on which the function is increasing. Well, it's increasing throughout. See, as you go across, see, it's always going up. So that was all we had to do. This is if it's decreasing. So if it were going down, then we would do B. And then C is if it were a straight line, a horizontal line. a constant function. Well, what else was there to answer? Oh, okay. We got to answer all of them. I'm sorry. All right. So the function is never decreasing, and it's not constant. If there were like a little flat piece in there. All right. So the function's domain. Well, if it's a function, all right. The range, you're looking at just the bottom portion. That's the only thing that we got to worry about, and that looks to be 4. So the lowest it ever gets is 4. And then it just keeps on going up to infinity. Find the x-intercept. There's no x-intercepts because it's going the wrong way. And then the y-intercept, there's just one, and it's at 5. 0, comma, 5. So f of negative 2, 1, 2, that looks to be 5. And then f of 0 is also 5. And that's actually the y-intercept. All right, determine whether the function is symmetric with respect to the y-axis. Now, this is not a function, okay? So this is one of those that's going to be laying, sideways. It's a parabola that's laying sideways. And so what it's symmetric about the x-axis. All right. So let's just kind of show you, because this is just like general. And this just kind of applies in every case where you have a non-function. All right. So say it fails the vertical line test, but it's symmetric about the x-axis. You know what? It's also symmetric about the y, isn't it? Was that a choice? It's actually all of them. It's symmetric about the origin. It's symmetric about the y-axis, and it's symmetric about the x-axis. So all of them. Let's just see something. Take that out. Yeah, because it's got that x squared in there. It's got both the y squared and the x squared. If it's got the y squared in there, we know it's not a function, and that'll make it symmetric around the x-axis. And then the other one, the x squared, essentially adds the x squared thing. Interesting. If it had just been x in there, it would just be the x-axis. All right, we're getting close here. In 2046, 46% of residents in a large city regularly use newspapers for getting news, and this is decreased at an average rate of 1.4% per year. So find a linear function in slope-intercept form that models this. All right, so Oops, that's not the right one. Oops, I clicked the wrong thing. All right, so we got a couple of ordered pairs here. Hold on a second here. It's really not that much to do. So there's the starting point. All right. So in 2000, it would be 46%. I'm writing it as a decimal. Plus point, and just remember, you got to get your decimals right on this. So 1.4 is 0.014 x. So that's all there is to it. It's not really that tough. But it starts out at 0.46 no matter what at 2000 because it says after 2000. And then every year it's decreasing. Whoops. It's decreasing. So it's decreasing. All right. Use the graph of f of x to graph the function f of negative x minus 2. So this right here is going to be that couple of transformations. All right. So f of x looks like this. All right. So it's got, first of all, it's got a negative 2 on the outside of the function. So what that's doing is it's moving it 2 spots to the right. I'm sorry, to down 2 spots down. So we can leave out A and C because it's outside the function. So the negative sign is true. It's pulling it down by 2. All right. Now, the negative x does the um, flip, the transformation about the y-axis. Let me kind of show you on here. I'm not going to do the same function since I don't know what it is, but that's not. I know we did this. I just don't remember why it's not like it. Anyway, let me just go back and show you by the definition of what that inside does. That was the last thing we looked at. So Where did they cover that? I think it was way down here. All right, so what this does is when you put a negative in it, if the negative is on the outside of the function, it reflects about the x-axis. Oh, I know why. That other one didn't work that I put on there because I'm not brain dead. It's because it's an even power. All right, see, reflection about the x-axis. It just doesn't work on an even function. All right, and that's kind of so reflection about the y-axis. See, it's the y-axis because it's the same on either side of the y-axis. If you follow the colors, now if you're colorblind, you wouldn't be able to tell, but this is the one function here. This is the original one. And then the negative on the inside flips it over on the y. So it's translated about the y-axis. I may have said x by accident. So which one of these translates on the y? In other words, it's flipping it like that, you know, like it's on the flagpole. So it's got to be this one because this one is exactly the same as that one. So there we go. All right. Use graph x-intercept, y-intercepts. Well, this is one of those things from 097. I'm going to refresh your memory about it. That's actually what I'm covering now in 097. So 3x, 3x minus 4y plus 12 is equal to 0. All right, so just what I'm going to put in here. Okay, so what does that mean? Now, the easiest kind of way to look at it, if I let y be equal to 0, then all this is going to be gone, all right? See, and I've just got like 3x is equal to 12, which is going to mean x is equal to 4. Oops. But let's just do it. We got enough time to put it in here. So y is equal to 0. So that means 3x minus, and 4 times 0 is just 0. I'm just putting it in there just in case people wonder what happened to it. So that's 3x is equal to 12, or x is equal to 4. All right, so what I've got here is I've got the point 4 comma 0. All right, so to do the other one, well, we do the opposite. All right, so x is equal to 0 now. So that means then that this part's going to stay. In other words, this time, this is going to be gone. All right. And I'm just solving negative 4y plus 12 is equal to 0. So that's going to be 0 minus 4y. And I'll just subtract, so that'll be equal to negative 12. So negative 4y is equal to 12, negative. So that means y is equal to 3. So that's the point 0, 3. So 4, 0, and 0, 3. So 4, 0, and 0, 3. There we got it. All right, so that's pretty much it, and we are just about out of time. We're great. Any questions? All right, because you got the task that's going to be on tap and should be finished by the time we get back. Okay, because Tuesday we're going to start on chapter 3.
You said the test is open until the 4th?